Ideas are powerful drivers of change. They fuel improvement and open up new possibilities. The first of its kind in the Philippines, in partnership with the Department of Trade and Industry, a fabrication laboratory, or Fab Lab, in Bohol, was established in May 2014 as part of a global network of local fabrication laboratories that nurture ideas. A space for co-creating, innovating, learning, and sharing knowledge. To foster local economic growth and community advancement through creative solutions, DTI, through Fab Lab, has identified 4 areas of development: innovation, MSME assistance, capacity development, and collaboration and partnership.
A Fab Lab is an interdisciplinary space that promotes innovation through the use of digital fabrication tools. It's a modern facility that allows our SMEs to do prototyping. For the last 1.5 years, we have been teaching them digital fabrication skills, which are very much in demand in the world market.
For us, it really would support creation of maybe high-end products and development of new enterprises that are technology-based.
This one will be the common service facility of industrial designing in the province of Bohol. There are even seminars, conferences, workshops conducted here so that Fab Lab enthusiasts and other designers could use the facility.
The concept was introduced to us by our Japanese volunteer, Mr. Yutaka Tokushima. He noticed in the course of his product development activities here, he noticed that a lot of the problems in prototyping could be solved if we had the right equipment to do it.
We've catered SMEs to really expand their market into the tourism sector.
We have all these industries, and ang thing is they're all kalat-kalat, and they're all spread out. And I think having this Fab Lab would bring them all together.
True to its thrust in catalyzing innovation, DTI, through Fab Lab and its local partners, has initiated key programs, projects, and unique initiatives in the areas of waste upcycling and material engineering. Prefabricated shelter designs, startup support and development, equipment development, and knowledge hubs for new innovations and technology-based solutions.
The timing man nga ning abot ang tagahapon nga mo naa sila ihatag. So mao to nga nalipay may kay ni ani abot ning kiwi house nga mo gi magkaroon na mo serve as daycare center.
Key MSME assistance initiatives such as product design, product development, productivity enhancement, and marketing solutions have been significant drivers in the improvement of grassroots entrepreneurs and homegrown innovators.
We do some native bags, placemats, wallets, curtains, and lately I do trophies and medals for the triathlon with the use of Fab Lab facilities.
The problem that artisans face here in Bohol are really the same challenges that any small business faces across the world, and that's how to get your product in front of your customer. So we developed a kiosk called the Made in Bohol kiosk and sought to have it located in the luxury hotels where the tourists were staying.
Pag butang nimo aning dating molder na mo, pag butang nimo, patigasin pa. In pila ka minuto pa usa pa nimo matanggal. Pero kini siya, gasigi pa mighimo ana, kasi mo iwa pa mahuman ng uban, pwede na mo siya itaktak kay gahi na. Wala na kay minuto o oras nga magamit aron pa mo gahi aron maputos. Kani siya diretso na. Mas daghan, mas napasayon, mas niangay ang among customer. So dako kay natabang ang Fab Lab sa mga.
Ang improved na siya nga sticker namo sa bagol na siya kay ang among canister is naka-embed man siya sa taklob. So kani siya sa bagol na siya. Okay, before, mag-cut out man ni, kami mag-print, ordinary lang nga band paper ang gigamit, kami na sila mag-cut. So, karon nga na-adirig, introduce siya sa DTI. So, nag-try ko nga magpa-print. Ganahan na sila. Sila, oy, nindot lagi mag-packaging. O, kaan lagi ni, klaro kaayo. Oy, sinaw na lagi ni. Kanang nga na siya na mga feedback ngayon, anak.
When FabLab came, we had this partnership with them para maging competitive din tayo sa market. So, eto po yung isa sa mga naitulong ng FabLab. This is our newest package na po sa mga placemats po namin. Madami po kaming nabenta na po nito and we're very thankful to FabLab. Tumaas po yung income ng kooperatiba. Kasi may added value po yung mga produkto na namin.
To fuel global industry competitiveness, local entrepreneurs, students, and innovators are brought together to equip them with 21st century skills and tools through digital fabrication, technology trainings, and livelihood trainings and seminars.
It's for everyone. I would say a lot of people really likes to make almost anything. Doon, merong bata, merong matanda, merong zero knowledge, merong may medyo alam na. When you see people came in and then yung parang may sparkly eyes sila dito, when they came like, oh, pwede pala to siya. Pwede palang gumawa ng ganito.
The Department of Trade and Industry conduct workshops and trainings for those because they want also to help those young local people here in the country. Because they want also to enhance their skills, improve their skills by the use of the FabLab Bohol. So, because FabLab Bohol, the concept of FabLab Bohol is to innovate and to create inventions by the use of digital fabrication.
This FabLab should be duplicated in other regions because this is a good avenue for developing the skills of designing on the students' part so that we could be ready or we could be at par with other countries in designing.
It's actually, for me, it's like a gold mine. A gold mine for innovators because everything are there na. Laser cutter, shop boot, 3D printers, Arduinos, mga testers na ito. As of now, there are so many micro and kitchen-based enterprises that would really need to improve or upgrade their technologies, their equipment. And that's why we are supporting FabLab because it is our vision that this facility could help those in making those customized equipment.
The FabLab affords its users access to global knowledge through regular educational tours and access to the international FabLab network. Local and other Philippine startup communities, enterprises, designers, and enthusiasts are encouraged to collaborate amongst themselves to expand and strengthen their niche in various market networks.
ボホールではファブラボを使って、必要なものを必要な分だけ作るというイノベーションが徐々に現地の人の手を使って生まれてきています。これは、他の国のファブラボでは見られないようなボホール独自のイノベーションと言えるようなものです。
The laboratory boasts of an array of digital fabrication equipment which include a laser cutter, 3D printers, a digital embroidery machine, a print and cut machine, a CNC milling machine, and an automated wood milling machine. FabLab Bohol also houses a pool of passionate in-house designers and highly skilled staff who can assist in 2D and 3D design, skills training, modeling, and production.
Our task here is to assist those researchers, innovators. So what we did here is not for us to create their idea, but them to create by themselves, and we will assist.
In partnership with the DTI, Bohol Island State University, DOST, and the Japan International Cooperation Agency, or JICA, and the local community of enterprises, FabLab stands at the center of innovation in Bohol.
We are very thankful of the help of the DTI. They can give you a very good service and you really can come up with a very good product.
Kasi we want to be Gandum Weavers to really soar high. And our partnership with FabLab will bring us to that level. So thank you po, FabLab and DTI.
I encourage everyone, especially taga Bohol, mga students, mga innovators, or mga out-of-school youth, try mo sa FabLab. If ever wala pa niyo nakita ang imuhang gusto himuon, no? Basin na mo kita sa FabLab.
It's a great privilege bitaw sa ato kay nga natagan pag chance nga matagan ng FabLab diri nga makita mo, ma-amaze mo sa mga magama ni FabLab, matabang niya para nato sa Bohol.
If you wanted to build a robot or night vision goggles or just something that lights in the dark, this is the place for you.
I would like to invite everyone to come at FabLab and let's play with these machines and let's work that idea out.
きっと皆さんのアイデアと、ボホールが持っているイノベーションがそのコラボレーションすることによってさらにもっと面白いものになると思います。ぜひ皆さんボホールにお越しください。
FabLab Bohol, a place where ideas turn into reality. Ideas that can improve lives, not just for Boholanos, but for all Filipinos.
Thank you, Engineer Basilius. So, any questions from our audience so that we can raise that up to our speaker for today? You may write all your comments or maybe your questions. If you have some concerns, you may write them in the chat box below for all our participants via Zoom. For those who have engineering services concerns, maybe this is our opportunity, so that we can maybe work with Engineer Ryan. Okay, maybe I can start with a question for you, Engineer Ryan. Is it okay?
Okay. Ano po?
Okay. So, maybe you can, yes. Hindi pa pala tapos.
Yes. Should I proceed?
Yes, please. Yes, please.
Okay. So for the main topic, for basic engineering simulation for a digital world. Yeah.
Hi, Sir Ryan. Walang audio yung video po.
Hello?
Before every innovation sees the light of day,
Sorry.
before every innovation sees the light of day, and every robot learns on its own. Before every fighter jet patrols the sky, and every soldier completes their mission. Before every automobile safely drives itself, and every rocket ship reaches the stars. Before every product is printed out of thin air, and every digital twin prevents a tragedy. Before every baby takes her first breath, and every virtual reality becomes reality. before every student has the world at their fingertips. And every patient gets his sight back. Before all this can become real, there is a designer, an entrepreneur, an engineer, a student, a scientist, a visionary, tirelessly working to create a better world, using the most powerful, the most pervasive simulation technology on the planet. Before every product delivers on its promise, there is ANSYS.
Hello? So, to proceed. So now, globally, we are using almost or designing the products digitally. So what does this mean to us? So digital engineering opportunity shows 60% of the company say it takes a year or longer to create new products from ideation up to product launch. So 85% of the companies say innovation is very important, and 42% of products in the industries like aerospace and defense are becoming more complex. So in order to grow the revenue and remain competitive in today's global marketplace, companies must shrink down the product development cycle time and get products to market faster. Oil, while being maintaining the constant evolving set of customer demands and the exponential increase in design complexity and growing skill gap combining to slow innovation at the time when there is a need to react faster than ever to the industry trends. So to thrive in this environment, companies must improve the productivity by digitally transforming their process to incorporate simulation. So like I said, the company that explore and refine the most ideas in the shortest times win. So to thrive in the environment, the company must improve productivity digitally, transforming their engineering processes to incorporate simulation. So a 2016 study in the Aberdeen Group focused on the top actions of the high performing companies. So to improve the overall quality of their product development cycle, which include 73% use simulation upfront or earlier in the development process. So 53% say that they promote collaboration between analysts and design engineers. 49% combine more multi-physics analysis. So this is to increase simulation realism. So to make it more real world. 42% capture the simulation expertise or the analyst expertise and make it more accessible to everyone. And 34% invest in the hardware that support the simulation. So these are now the trend going globally. So to give you a more detail of the pervasive simulation, I have a special guest directly from ANSYS headquarters, the CEO of ANSYS himself, Ajay Gopal.
It is not an It is not an exaggeration to say that we're undergoing the most fundamental change in manufacturing. It is not an exaggeration to say that we're undergoing the most fundamental change in manufacturing since the introduction of the assembly line more than a century ago. Trends like the Internet of Things, additive manufacturing, and machine learning are merging the physical and the digital worlds, resulting in products that defy the imagination. But it's not just the products themselves that are becoming smarter and more exciting. This disruption extends to the way they're being manufactured, the way they're being brought to market, and the way they are being operated, from highly automated factories with mass customization capabilities to drone deliveries and digital twins. This transformation is already happening today, from industries as diverse as industrial equipment to consumer goods to healthcare. Take the example of a pump. Now, a decade ago, this would have been a metal mechanical device. Today, however, the pump is very different. Now it includes onboard electronics. It includes wireless communication. It's made with multiple composite materials, and it's being deployed in environments as varied as a mountaintop in Alaska to the sweltering dunes of Saudi Arabia. Now, according to the Boston Consulting Group, this merger of the physical and the digital represents around $11 trillion of annual value that's just waiting to be created. Our customers, those visionary companies that produce airplanes, industrial pumps, smartphones, medical devices, our customers will be well positioned to capture this opportunity. The opportunity is the good news. The downside of this revolution is that the level of product complexity that these changes will require will be enormous. Think again about our example of the pump. The engineers developing that machinery must now consider onboard electronics, composite materials, 3D printing, and customization that might be required by their customers. The engineers' jobs are orders of magnitude more complex than in previous generations. The winners of tomorrow will be the companies who can master this complexity and can harness its potential to create breakthrough products. And that is where ANSYS can help. ANSYS was founded more than 45 years ago with the idea that we could help organizations create better products through accurate simulation. Whether they're developing microchips for the latest consumer gadget or potato chips to satisfy your hunger. And since then, we have helped companies large and small to innovate by creating digital prototypes of their products and by accurately simulating their behavior. Over the years, engineering simulation has become more and more mature. We have developed the only platform that can be truly considered to be multi-physics in an integrated fashion, enabling engineers to simulate more complex physical phenomena in the computer. Compute power, usability, these are no longer constraints for the effective use of simulation through the product development process, which stretches from design exploration to concept design, then to detailed design, and then to validation. In the safe confines of their computers, these engineers can break a product thousands of times if necessary,
They can create millions of permutations until they find exactly the characteristics they need for their product's performance. When engineers are developing these products, we know they employ a number of technologies. And yet, they consistently point to engineering simulation as one of the top tools that will transform product development over the next decade. And that makes sense, doesn't it? Product complexity is increasing even as the capabilities of engineering simulation are growing. And the tools? Well, the tools are easier to use than ever before. So it's not surprising that we're seeing engineering simulation becoming more and more pervasive across the entire product lifecycle, as well as with all types of engineers. In some cases, we're even seeing engineering simulation used by non-engineers, like doctors and biologists. While simulation was once the sole domain of experts and used mainly for verification, it's now moving up front in the development process to quickly evaluate changes and designs. And at the same time, it's also moving downstream of the product lifecycle process to analyze real-time operational data from connected machines in the industrial internet. We call this expansion of our tools pervasive engineering simulation. Now, simulation's pervasiveness isn't surprising because we're growing the applications for simulation technology. We are building into our software the ability to simulate the behavior of thousands of composite materials, to add warping and breaking of a PC board, to understand how components are wired and what power runs through them. We can simulate not only the electromagnetic behavior of an antenna, but we can digitally place it in an operating environment to determine how it will perform in the real world given the interference with other arrays. Companies large and small are doing this today, and they're realizing fantastic results. Now, one such organization, Cummins, wants to make people's lives better with its engines and power generation equipment. An ANSYS customer for nearly 3 decades, Cummins uses simulation to create digital prototypes of its machinery. And now, joining me from Cummins headquarters in Columbus, Indiana, is Bob Tickle, the Director of Structural and Dynamic Analysis. Bob is a longtime ANSYS user who has seen firsthand the power of simulating digital prototypes. Bob?
Hello, and thank you for letting me join you virtually today. Throughout my career at Cummins, modeling and simulation has always been valued and utilized. However, in the early 2000s, there was a big initiative that was driven top-down from our chief technical officer that he called analysis-led design. And that was really about moving from a test-centric culture to an analysis-centric culture, with the benefits of reduced testing and saving money, but also being able to open up our design space exploration, doing things in the computer that you just couldn't do in the testing world. So we've been doing that for about 15 years now, and this success story is there. And those areas are really around reduced testing, minimized testing. We've seen that happen. We've seen design exploration happening in a whole new way. And in fact, we're doing things today around systems modeling and understanding lots of trade-offs that we could only imagine doing just a few years ago. So we continue to grow in that area. We're also doing things around design for environment, where we're saying how do we minimize the material that we use in each component and reduce our carbon footprint, which also equals lighter components and ultimately less fuel burned by our customers down the road. ANSYS has been a strong partner before our analysis-led design initiative and after. We continue to have very open communication, work with them regularly. We really value that. We've been mechanical and fluent users, CFD users for many years, so that continues to be strong. We're growing in the area of electronics, and we're also doing projects around multi-physics and doing systems modeling. So with the ANSYS portfolio, we look forward to the future and continuing to better understand our products and in getting our designs right the first time.
Thank you very much, Bob. You can see how the strategic use of engineering simulation has helped Cummins cement its status as a market leader. But organizations don't need to have decades of experience and expert engineers on staff to take full advantage of simulation. Take a much younger company, Nebbia. Now, I love telling this story because nearly every company was in Nebbia's place when they first started, in a garage. The founders of Nebbia were looking for ways to ease the terrible drought that has stricken California in recent years. And their solution? The solution was to re-engineer something that many of us take for granted. The shower head. Nebbia wanted to provide an amazing shower experience, but to do so while saving water. But this small company didn't have teams of engineers. They didn't have decades of product experience to turn to, nor did they have the time to create numerous physical prototypes. So they partnered with ANSYS to build a digital prototype to dramatically shrink their time to market and to create a pretty amazing product, one that saves 70% of water compared to standard shower heads. So we're now going to go to Nebbia's San Francisco office to hear directly from its co-founder and chief technology officer, Gabriel Parisi-Amon. Gabriel?
At Nebbia, we believe that thoughtful design and research can produce products that use resources efficiently and that people love. We're a startup based in California, and our first product is a shower system that atomizes water into millions of tiny droplets, providing a better experience and saving 70% of water versus a regular shower head. As a young company, we optimize for speed and cost. Using simulations allows us to move quickly and in the digital world, test hundreds or thousands of ideas in the time it would have taken us to test only dozens. It also allows us to reduce costs in prototyping and making physical samples of what we are trying to make. At Nebbia, we've used ANSYS to optimize the user experience and to reduce the overall size of the Nebbia shower system. At Nebbia, we use industrial nozzles to make a warm, enjoyable shower that uses a lot less water. Using ANSYS, we were able to iterate through thousands of different nozzle arrays to make the best possible shower. We also use ANSYS to optimize the internals of Nebbia. Many of these industrial nozzles are meant to be used at the end of long tubes or on manifolds. We had to shrink 10 nozzles into an elegant enclosure. Using ANSYS, we were able to do this and make a shower that is easy to install for users and looks great. The results have been phenomenal. Over 1,000 people have showered under a dozen different generations of Nebbia prototypes. And last year, we launched a Kickstarter campaign that lasted 30 days and raised $3.1 million. This month, we are delivering the first Nebbia units to our customers.
Thank you, Gabriel. And congratulations on this great achievement. I love how you went from 1 to 2 product iterations per month using physical prototypes to thousands a week using digital prototypes. And I'm looking forward to installing the Nebbia shower heads here in my new home in Pittsburgh. So as you can see, creating digital prototypes helps companies of any size to innovate their products, to bring those products to market faster, to better compete in the marketplace. As engineering simulation becomes more pervasive, it can play a much larger part in the product lifecycle by moving beyond verification and validation. As simulation expands from the analyst group out into the product designer ranks, it can empower more engineers. These design engineers don't spend every waking hour in simulation, but rather they're occasional users who can employ simulation to digitally explore the what-ifs of their products. That initial product design, that initial product sketch determines quite a bit about how the product is actually going to behave in the real world. The sketch shapes the future performance, and it locks in a large part of the total cost of product development before the engineer has insights into the actual behavior. And today, that's often happening with CAD. Now, CAD can document a design, it can specify a design, but it cannot predict a product's behavior. And that is where simulation shines. Imagine pushing simulation up front in the product lifecycle, giving engineers insight when they're literally at the drawing board. We see our customers taking advantage of that today. Companies like Denmark-based Oticon, which is improving people's lives by helping them hear more clearly with the use of technology. Now let's go to Copenhagen, where we'll hear from Oticon simulation specialist, Martin Larsen. Martin?
Thank you. I'm Martin Larsen. I work at Oticon as a simulation specialist. I do tool development, so I basically built the tool shop that my colleagues are using in the projects to do simulation of hearing aids. We basically use simulation to understand what we're doing. We use it to reduce the number of prototypes and make sure that we're not fumbling and wasting expensive development time. So risk in our projects is reduced because of simulation. We simply get a better starting point when we have a simulation model than without one, and we get much better understanding of the design that we're making. To us, it means a lot that the tool itself is not the obstacle. It has to be the engineers should use their mind power on design and fixing problems much more than on struggling with a tool.
Thank you for filling us in on this great use of simulation, Martin. Now, there are many reasons to use simulation early in the development process, but time to market and cost are chief amongst them. About 80% of a product's development costs are locked in early in the product lifecycle, and that makes rapid early iterations critical so you're not stuck with an unworkable design when you get to the validation stage. By performing very quick what-if analyses, we can study the multiphysics behavior of a product early in the product lifecycle. We call this digital exploration. And it brings innovation to market faster and less expensively. And that's what Metso is doing. Based in Finland, Metso is helping to power the world by providing equipment for the mining, the oil and gas, and the aggregate sectors. By using simulation early, the company generated design alternatives 20 times faster, and they analyzed huge models in mere hours. Now let's hear from Jukka Boriman of Metso now. Jukka?
So thank you. Metso is a global manufacturer of industrial valves. For more than 90 years, we have been providing these valves for our customers in oil and gas, pulp and paper, and other process industries. Our customers will see the benefits of simulation by increased performance, safety, and reliability of our products. Internally, we are getting the benefits in speed of product development. So we are able to cut down the number of laboratory tests because of the simulation. And because of the reduced number of laboratory tests, we also are able to cut product development costs by simulation. A third thing would be the quality of our design. Since nowadays with the simulation tools, we are able to do more and more iteration loops in the same time period than before, so that will be actually increasing our quality of our designs. Thank you.
Thank you, Jukka. That was a great job. As I mentioned earlier, pervasive engineering simulation isn't limited to the product development process. We are seeing simulation move into operations, where real-time simulation is providing insight into an individual product's performance and maintenance. These digital twins represent the specifics of an individual product in its operating environment. Take a turbine in a power plant. Each of these unique turbines transmits gigabytes of sensor data representing its operating state. Using that data, the digital twin can be used to run simulations to optimize the performance of the turbine or to identify potential failure modes. Now, this represents a fundamental change in equipment manufacturers' business models. Instead of selling boxes, they now sell results. Analysts expect digital twins to drive 20% efficiency gains, and early adopters are already seeing performance improvements by over 10%. At an industrial scale, the potential savings are massive. GE estimates that the use of digital twins in its power plant could save $230 million over the 20-year lifetime of a turbine. Now you multiply this number by the number of power plants and by the number of turbines, and the potential becomes truly staggering, on the order of $75 billion, and that's just for one industry. Now let's hear directly from GE, which is a digital twin trailblazer. This industry visionary has rebranded itself as a digital pioneer, combining the digital with the physical to improve our lives. And from San Ramon in California, Here is GE Digital's Chief Marketing Officer, John McGee. John?
Hi, I'm excited to be with you today virtually, and we're also at GE very excited about the opportunity around the industrial internet. So when you think about this potential that we see here, it's all about the power of connecting to what we sometimes call the Internet of really important things. Business critical, mission critical, industrial infrastructure and assets. And through the industrial internet and the technologies it provides to connect to those assets, to collect data, to be able to use analytics and simulation to really bring that data to life, get better information and insights about how to operate the global industrial infrastructure, how to achieve the optimizations that our customers are looking for, that we're looking for at GE, is a tremendous opportunity. Then we are all in on this across all of our business units, across everything we're doing at GE because of the potential we see here. When you think about it, industrial assets and managing these areas, one important concept is this idea of the digital twin, this idea that every physical device, whether it's a piece of equipment or a whole plant, has a digital representation that gets smarter and richer the more data and analytic insights we can feed into it, and the more collective wisdom we have from looking at all of the types of that equipment around the world. And the opportunity here is to really start to be able to get better visibility, better control, and better decision making. And simulation is a hugely important part of that. So when you think about the design, manufacturing processes, simulation modeling have been used for many years, and we continue to get a lot of benefit in those phases. But we're also excited about the operational side. Once equipment is put into place, the ability for decision makers or asset operators to use simulation technologies to ask what-if questions about how to manage their infrastructures better is huge potential. And we've been excited and happy to work with ANSYS and their simulation capabilities to really take this to the next step. And the combination of our Predix platform for building, managing, and monetizing industrial IoT applications with ANSYS simulation tools is a great one-two punch for our customers.
Thank you, John, for helping to illustrate the power of digital twins. Well, we've now seen the classic use of engineering simulation for test and verification of designs. We have seen how simulation is moving upfront to be utilized early in the design process to provide insights on the choices made at the outset of product development. And we've seen how simulation is moving downstream to operations to create digital twins that are specific to individual pieces of machinery. And today, I'm proud that we're announcing ANSYS 18, which is our next step to making pervasive engineering simulation a reality for all manufacturers. Now, more than 45 years ago, ANSYS established its leadership in engineering simulation, and with ANSYS 18, we continue the track record of providing the best simulation tools on the market. ANSYS 18 is a feature-rich release that deepens and strengthens each of our major physics areas. It also expands the boundaries of simulation, as I've just explained. Now, in a few minutes, you'll have an opportunity to learn more about our latest release from the people who've put in countless hours making it a reality. So please, take the time to listen to our breakout sessions after we conclude here. You'll be able to hear from and ask questions of the development leaders across many of our key product lines, from structures to fluids to electromagnetics. As I mentioned at the beginning of this presentation, we are facing the most fundamental transformation to manufacturing in a century. Combining the physical and digital worlds brings enormous opportunities as well as enormous challenges. Pervasive engineering simulation can help tame the complexity inherent in this new world. Expanding simulation from its traditional role as a validation tool and bringing it to new engineering audiences throughout the product lifecycle will spur innovation. It will lower development costs, it will lower operational costs, and it will improve time to market. I am incredibly bullish about the opportunity ahead, and all of us at ANSYS are excited to be part of it. Thank you so much for your time today. Now please hold on, and you'll be instructed on how to get back into the breakout sessions.
Thank you, Mr. Ajay. So you already spoken a lot about what ANSYS can do and the benefits of simulation, which the global companies are now benefiting. So simulation is a proven technology. It has delivered tremendous benefits, like reducing the warranty cost. Sorry, reducing the warranty cost, reducing the development time, and increasing the on time or market launch. Sorry about that. I'm having some technical difficulty. Hello. Hello. Yeah. So like I said, the simulation delivered tremendous benefits, but for only a tiny fraction of engineers and production decisions so far. So typically, simulation is performed by expert analysts. So, but the goal is to engage a broader range of engineers upfront the simulation stage. So this is a typical example how technology is always evolving. Hello? Hello? Technology is always evolving, and when things become pervasive, there are organizational changes. Think about it as number of people using technology is expanding exponentially. So the way we communicate has evolved over these years. The capabilities began with Pigeon. So it's offering strictly point-to-point communication. The Pony Express, but the question is it sustainable or scalable? The telephone, which is a connection at a new level offered to a specific group, class of people, and as technology became more pervasive, it doesn't tie you down. So what is the impact of this technology? So say if 5 people had cell phones, does it make an impact? Or if social media like Facebook only had 500 people, so would it make an impact? But if 1 billion people uses it, it became transformative or disruptive. So as the point is, as the technology becomes pervasive, it has profound effects on how we operate in the society. So as simulation becomes more pervasive, how will it affect the way engineers, designers, or organizations operate? So that we will answer later on. So like Mr. Ajay said, the digital revolution is making the problems even harder. So like chips in the electronics are getting more complex. Electronics are everywhere. So we have a lot of smart devices. Products are made of increasing complex composite materials. Every product will soon be connected, smart. Additive manufacturing is transforming the manufacturing industry. And the Internet of Things is changing the way products are delivered and maintained. For example, in the aerospace, there are a lot of variables that the developer or the designers encounter. In defense, there are also a lot that needs to be solved. And all these things are really expensive if you are doing the traditional prototype and testing. So the answer is simulation. Simulation enables the product managers to drive the innovation, manage the complexity of the projects, reduce the time, and increase the quality and eliminate the risk. So which is driving simulation usage? Because of the complexity of the product, the demand, the consumer demand to make products to market faster, and the quality of products significantly increase. So where simulation go from here? So in order to become more pervasive, ANSYS developed tools that lets you use it in all the or across the entire life cycle of the product. So starting from the ideation up to the detailed design, then you go to large manufacturing or industrialization. Even if the product is already at the customer running 24/7, you can monitor how the product would behave in the real world using the digital twin in product, which also incorporate the sensors and some functions. So these platforms which or solutions are listed here. So these solutions are the best in the simulation world. So like recently, LS Dyna is the leader in safety crash analysis. So ANSYS acquired LS Dyna, and now they are offering ANSYS LS Dyna as part of their structure family. But like I said, if you have great power, you also have comes great responsibility. So as solutions or problems become more complex, these solutions also needs expert or analyst. So how ANSYS deals with this problem? So they offer this ANSYS Discovery package. With the Discovery, you can explore ideas digitally. So from 1 to 2 prototypes per week, you can test up to 1,000 per week. So not even jumping to the design or detailed design category. So the design challenge for today is, as product development cycles are getting shorter and the complexity continues to increase, so the most design ideas in the shortest times wins. So digital exploration of many options, uncovering the promising ideas, refinement, detailed design to narrow down the specifics, and then validation. So, but what is the current state of simulation nowadays? So the majority of simulations are performed late in the design cycle. So mostly by a small group of experts. So normally the design engineers do their best to design the product as per customer demand. So later on in the product lifecycle stage, an analyst refine the products and then do validation, and then submit it again to the design engineer. So this is the traditional approach using the current simulation tools. Like Cummins, they said that before they thought that they are doing simulation-driven design. But after the ANSYS Discovery, they want to do the simulation driven design. Oh, sorry. So before they thought that they are doing the simulation driven design, but they're doing the simulation driven validation. So to give you an idea, so this is a design engineer like myself. So if I had ideas regarding the products or the machines, normally I talk to the expert analyst regarding such a solution. So it will take him days or weeks to refine or go to the process of traditional simulation. After which I will go to prototype my idea and then do a validation or physical testing, which already have an impact to the product life cycle timeline. So the opportunity is there are more design engineers than expert analysts in the company. So the ratio is normally 10:1. So why don't design engineers use the simulation? So these are some of the reasons. It is difficult to learn and use. Simulations takes too long, especially in the early ideation phase. Too complicated, too expensive, CAD embedded tools not capable enough, difficult to move from ideation to validation. So normally, expert analyst time is often wasted on simple simulations. The result is longer product development times with less innovation and fewer ideas explored. So with ANSYS Discover Live, it is the first real-time simulation, instantaneous simulation for rapid design exploration, high fidelity, and multi-physics. And of course, it is designed for extreme ease of use. So anyone can use it. So to make it more pervasive ideation phase, you can already explore digitally your ideas using ANSYS Discover Live, using the real-time simulation tools. Then, after you or the design engineer have his concrete objectives or design, you can go to the expert analyst to further refine it and do validation or physical testing.
Disruptively simple, simply revolutionary. The world of product design has just been redesigned. Introducing ANSYS Discovery, simulation technology specifically built for the design engineer. Uniquely built to develop concepts fit for their purpose. Early design concepts that come with directional guidance, validation, and proof of performance. Highly interactive in nature, the Discovery environment supports full 3D editing. Discovery works with all common physics types and simulation applications. Quickly make multiple changes and instantly know the performance impact. Instantly validate your concepts without waiting for geometry modifications, meshing, or solving. Choose higher fidelity, high accuracy studies to carefully refine the best of your ideas. Designers can now iterate, refine, and interactively explore the impacts of hundreds of design options in a fraction of the time previously required, saving time in the development process and resulting in better products. Make a geometry change. Discovery instantly begins recomputing the results without starting over. Refine an idea, validate a concept, rapidly change direction, and receive guidance. Explore several possible design directions never before considered. follow and test a specific design path more thoroughly, more confidently. Perhaps best of all, the Discovery family of products is simple to learn and easy to use, bringing new and exciting insights to every designer. As quickly as designers can generate questions, Discovery tools can provide the answers. This is the promise of rapid design exploration made simple. Because every engineer deserves the power of discovery.
Let's look at some features of ANSYS Discovery Live that truly make it a disruptive software for the product development process. You should know that everything I'm about to show you is performed in real time on a simple engineering laptop. No supercomputing clusters or cloud-based simulation infrastructure, just real-time simulations and real results. In this first example, we'll look at a complete detailed model of a tractor's rear axle assembly. I want to better understand where high-stress regions are located. I know there are several fixed locations and a force applied. Once I complete the minimum number of inputs, I can see exactly where the highest stress values are located. Normally, this type of feedback from simulation would take hours or days. In Discovery Live, it literally takes seconds. Based on that initial feedback, I want to reduce the stress in this area. I'll quickly add some ribs to the design, something I've previously mocked up, and once I merge everything, the results come instantly. I can see that the second rib doesn't appear to be helping much. When I remove it, I instantly see the new results, which tell me I don't in fact need that rib. Instant design direction on 3 iterations in less than a few minutes. We'll move to a fluid flow study where you'll see the same power and ease of use in Discovery Live. My goal is for the flow to uniformly distribute through both outlets. After I designate the inlets and outlets, results immediately appear. Discovery Live makes certain assumptions for you, such as the flow rates, so you can quickly see the results and trends. There are several ways to observe the results, such as streamlines, an LIC plot, or contours of velocity magnitude. Since most of the flow is going out the bottom, the question is what sort of changes can I make to remedy this? If I include a splitter in the geometry, I instantly see what effect that has on the flow. Of course, I can quickly change its angle to better equalize the flow. A flat baffle works, but I think I can do better. A curved baffle will probably lessen the pressure drop while better distributing the flow. Now, as I have new ideas, I can test them in real time. What happens if I translate the splitter? Results instantly appear. What happens if I add a second baffle? You can see how quickly I can analyze design ideas in a few seconds and better determine the best design direction. Let's look at a thermal study where I have an electronics enclosure. Inside there's a green control board and a pink heat source. My goal here is to perform a basic simulation of temperature on the control board. After applying a heat flow of 50 watts to the pink body, Discovery Live quickly returns final temperatures. Applying a plot of the temperature, you'll see I'm sitting around 72 degrees Celsius on the top face. Now is where things get interesting. In Discovery Live, my inputs are editable. I'll change the air convection to something more representative of natural convection instead of forced convection, and you'll notice the temperature increases over 4-fold. Quickly adding a primitive heatsink instantly drops the temperature, but I still have some room to improve. As you saw before, modifying geometry is no issue at all, regardless of the model's origination. Every time I add a fin, the temperature drops, and I'm sitting around 150 degrees Celsius now that I've doubled them. Any other edits I conceive are easy to do, and since my heatsink now interferes with the housing, I'll have to customize the height accordingly. It's simple to drag faces and fine-tune until I'm satisfied. I've changed the geometry and one input, but another input to change could be the material, and I instantly see the effect from doing that. At the end of the day, my questions are quickly answered in Discovery Live just as fast as I can change inputs or the geometry. In a final example, we'll jump into an external airflow study to not look for highly accurate lift and drag values, but to observe trends in the airflow around the vehicle. And as before, setting up a simulation requires minimal inputs to get instant simulation results. What I'm curious about is the effect that a top deflector will have. With a handy sketch tool, I can mock up my concept and transform it from 2D to 3D. The solution updates, and I have instant feedback. Discovery Live can also do unprecedented, complex simulations, like showing instant results for the flow of 2 vehicles, all in real time on an engineering laptop. It truly is a powerful environment for designers to experience the benefit of simulation and take product development to the next level.
So that's a little glimpse of the ANSYS Discovery Live. So as you can see, it is a real-time engineering simulation, which literally anyone can use. But for us, design engineers, it's a powerful tool that let us test thousands of ideas, literally real time. So we don't need to design, create a prototype, and then test to validate our ideas. But one constraint for the simulation is also materials. So with this, we have Granta material database. So Granta is a unique software dedicated only for materials. So we have Granta for material data for simulation, which is a add-on to the ANSYS family. The Granta selector, which you can use to filter out or helps you to find the right materials on your project. Before, the material used globally is not that complex. Nowadays, the materials the materials nowadays is highly engineered. That I would like to say. So, meaning it is more complex. So that's why we have the Granta selector to further filter out all the requirements in a project. We also have the Granta MI Pro, which manages all these materials and share it to the whole team, from CAD to the designer to the analyst themselves. And we also have the Granta Enterprise that takes even further the data management for example, the material specialist.
Every simulation analyst wants to boost the accuracy of their simulations. At ANSYS, we have developed materials data for simulation, or MDS, using our Granta materials expertise to bring you accurate materials data to boost your simulation accuracy. What is MDS? MDS is a simple bolt-on for your flagship ANSYS simulation tools. Quick to install and easy to use. One of its key features is that it is data you can trust. ANSYS Granta is a market leader in materials data, providing data on both generic material types and individual grades. MDS is built on this and provides a trusted source of data on over 2,600 materials and over 20 property models, suitable for structural, thermal and electromagnetic analysis, amongst others. A second feature is that this data is simulation ready. It is ready to go saving you time having to search, check or transform data from a variety of other sources. Less time searching, more time solving. Finally, because MDS is directly embedded and built to work with our leading ANSYS simulation tools, you can access this trusted, simulation-ready materials data in just a few clicks in all the ANSYS flagship products. So there you have it. MDS is all about bringing you trusted materials data from the market leader in a simulation-ready format that's directly embedded in the simulation tools you use today, all to boost your simulation accuracy. Every simulation analyst wants to boost the accuracy.
Here are a few examples of a case study and the stages from which you can make or do the simulation. So like this styling, which with the physical accurate light simulation. So mostly for automotives. And here you can see that we are still on the ideation stage. On the design stage, nowadays we have electrification. So ANSYS provides the most comprehensive multi-physics simulation and software platform for the automotive electrification. So from softwares, thermals, electricity, fluid, structural, magnetics, and electrochemical, and the systems running on board. Here's a example of Lucid. If you know, Lucid is a competitor of Tesla. So they are using ANSYS to model their electric powertrain, battery, transmissions, and so on. Also, autonomous vehicles. So ANSYS is building the only comprehensive autonomous vehicle solution that can accurately test millions of driving scenarios. So closed loop simulation, sensors, safety, electronics, semiconductors, and softwares. So this is a example of the autonomous vehicle running in simulation. So on the left side is the traditional rendering. On the right side is ANSYS with the physical accurate simulation. For manufacturing, we have the additive manufacturing. So it's a complete design to print solution, confidence without trial and error, and a truly successful additive manufacturing production. So as you can see, this is stages that of what you can use ANSYS for additive manufacturing, from your over-designed products, topology optimized, validated, physics-based support, and then print process simulation. And you can also analyze the microstructure of the product. So ANSYS simulation tools enables customers to consider the entire additive manufacturing process chains. So including the topological optimization, the validation, the build setup, and the support generation, and also the build failure prevention. So on the slide, you can see the original geometry, and on the right side, a compensated geometry to counter effect the warpage or the distortion of the model. So these are common techniques that are now being utilized in the industry. For operation, we have the digital twin. So this is an example of a digital twin of a gear with a magnetoresistive sensor. So here is a normal graph showing no errors or no problems on the gear. And as you can see, the graph changes when failures occur. So using digital twin, you can eliminate the risk or study the risk even before it will happen. And lastly, in product is more on the software's functional safety and cybersecurity of your products. So here are more examples that uses the simulation tools that we have. For the aerospace, the structures of it, crashworthiness, bird strike lightweighting, the aerodynamics, the safety environment of the cabin, and all of its mechanical systems. And of course, safety. So to summarize, we have a lot of challenges nowadays. The solution is a cross-functional workflows and simulation platform, integrated functional safety and embedded software, which we have reduced iterations and achieve our gateways, predictable design, in-house competence, improve reliability, meet the safety objectives, and improve the product supplier cost structure.
Rossignol has a strong position, of course, in this winter sports because it's a position that we have since 1907 and we are proud of it. We have only one winter per year, and during this winter we have to shorten all the process. Shortest ideas, shortest prototyping in order to go as fast as possible on the snow to make the test. So we have to be very reactive. So this kind of headquarters here gathers all the facilities that we need in order to go the fastest as possible from the idea to the prototype. So when we want to come up with a new product, all starts with brainstormings and the interactions between the team R&D, marketing, design, in order to bring new solutions of materials, shape, and of course to take into consideration what the users ask for. Our relationship with AMCEN started almost 20 years ago. Modelization by the past for us was rather an expert tool in order to solve the problems. With Discovery Live, this modelization come earlier in the project. It really changed the game because to be able to involve not only experts like we used to do, but with different kind of technicians in our R&D design departments coming from CADs or from designing software to be able to get inside the project and to shorten the processes.
Discovery Live is very, very useful when we are in a meeting with other departments. We can see how the part is going to react in reality. We don't need to wait 1 week to make a prototype. In 1 hour, we can see 5 or 6 different parts and make a decision. With a normal software, we cannot do that. It's impossible.
With this technology, we are able to share with R&D all our ideas. It could be lightness, performance, design, because on the marketing side we have many ideas. It's also really visual for us, and it's a good way to demonstrate the benefits of a technology to the consumers.
Ross in your group is not only involved in the ski equipment products. The new products like cycling for us is really important in our strategy. And we are eager to start with these Discovery Live tools, offering new facilities of modelization, both in mechanics and aerodynamics. And I know that the teams are really enthusiastic because innovation is involving everyone in the company, in a group. So for us, Discovery Live makes sense in order to have better ideas, better solutions, and then more innovative products to come on the market.
That concludes my presentation. I hope everyone likes it. For more information, you can visit the links, follow us on LinkedIn, or email us to if you have any requirements, engineering solutions, and so on. Thank you very much, everyone. And also for trials, if you want to try the Discovery Live, so you can download it free on the link below. All tutorials and also download links to download Discovery Live. You can also visit our LinkedIn page. Thank you.
Thank you very much, Engineer Ryan. So for those who have questions, maybe you can chat. You can encode it in our chat box below. So by the way, we have some questions earlier. I'd like to raise it up right now. This is from Gerald James. Are these, by the way, this is for you, Engineer Ryan. Are these softwares or any of the products can be covered by any form of engineering insurance?
Hello, ma'am. Can you repeat that? Sorry.
This is from Gerald James. Are these softwares or any of the product can be covered by any form of engineering insurance?
In my experience, I did not encounter any insurance regarding this matter. But I will double check.
Okay, thank you for that, engineer. Also, we have another question here from Albert Belchez. For simulation, are there any limitations on graphics design software that can be used? What is the best software that is compatible for your simulation software? Again,
graphics design. For what I understand, graphics design is mostly used in industrial design stage. Also, in an ideation process. But ANSYS supports general formats which I in my knowledge is also, like for example STL, STP, and some general formats that can be acquired using the graphics tools, the 3D graphics tools. Sorry.
Okay, thank you for that. I hope it was answered, Albert Belches. And I think maybe this will be the last question due to some time constraints. This is from Ivana Rojo. So good afternoon po. I am a fifth year chemical engineering student. Curious lang po, nakaka-overwhelm minsan since madami po kailangan gamiting software. I like to work sa oil industry and I want to know if I can apply ANSYS doon sa chosen industry ko.
Yes, like I said, ANSYS is now used in every industry, including the oil and gas industry. So one particular example is the digital twin, which they like the oil rig, they already developed the digital twin of that product with a lot of sensors and so on. So the answer is yes. So you can implement it in the oil and gas. And also for chemical engineers, ANSYS also support mixing of chemical simulation. So that also you can do.
Okay, thank you. We also have here another question. By the way, this is from DOST MIRDC, Sir Coronado. So hi, sir. For CFD, I observed ANSYS to have multiple flow simulations such as CFX and Fluent. Can you help us to understand more what is the difference of CFX and Fluent? Thanks.
For ANSYS has, like I call the entry-level softwares, which includes the discovery and also some particular solutions for a specific industry, like for electronics, which includes electronics cooling and fluid dynamics also, and for Fluent, which is used for advanced CFD, like for NASA, they are using Fluent for the hypersonic speed of their rockets. But for early design stages or not that specific solutions, we recommend to start with the discovery.
Ay, naku, marunong ako. Yun talaga ako. Napatay mo muna yan.
Oh, we also have here.
Patay mo yan.
Okay, good afternoon. From Sir Coronado still, no? So does ANSYS support STL files directly? If not, what files does it usually use or stable to work with?
Sorry, ma'am, can you repeat the question again?
Does ANSYS support STL files? If not, what files does it usually use or stable?
Parang yun, 6 na yun.
Sorry, ma'am.
Miss Maria Feta, please mute.
Wala po yung sound niyo. Hindi ko marinig.
Okay, okay, kani. Is it clear now, Sir Ryan?
Yes po.
Ito po, does ANSYS support STL files directly po? If not, what files does it usually use or stable to work with?
files. So, like I said, ANSYS supports all the traditional CAD files like SolidWorks, NX, CATIA, ProE, but it also has its own file format or CAD system, which is shown in the Discovery Lab. So theoretically, any files, CAD files that you can produce can be used or uploaded to ANSYS.
Okay, thank you. I think there are no more questions. And for those who are interested, maybe to reach out with our speaker for today, we have flashed on our screen their email ads and their websites. And I think there are free trial downloads for ANSYS also. So I suppose ANSYS Discovery software is something our design engineers should look forward into, no, instead of utilizing the conventional simulation. So thank you very much, Engineer Ryan Clavecillas. I think that concludes our webinar for today. It was so informative, and I hope everyone has now boosted up into another level of simulation. So I think it would be good to end up this webinar with a photo op. So I'd like to request everyone to turn on your video so that we can maybe have a photo op with our speaker for today. Okay. Sir Ryan, pwede po ba natin i-stop share muna yung yung screen? Para ma-picture lahat. Okay. Okay. First. Next slide. Okay, thank you very much. And by the way, this is Christine, your host for today. Have a great day ahead. Thank you very much for all who participated this webinar. Have a great day. Thank you.
Yeah, thank you and stay safe, everyone.
Stay safe.